This topic is about finding exact trigonometric values using trigonometric graphs and SOHCAHTOA. I will not be teaching cast in this lesson or any lessons. Okay, so what you realize is when you draw all the graphs, so y equals sine x, which is the blue one. Oops. So y is equal to sine x is the blue one. Y equals sine x. And then y is equal to cos x is the red one. And y is equal to tan x is the green one. And then if you split up all the graph into 90 degrees, so every 90 degrees, so pi over 2, pi, 3 pi over 2, and 2 pi, then you can see all graphs are positive in the first 90 degrees. So all. In the second 90 degrees, so between 90 and 180, you can see the blue graph is only, so if I highlight it, only the blue graph is above the x-axis. So the blue graph is sine, so only sine is positive there. In the third quadrant, or the third part of the third 90 degrees, which is between 180 and 270, you can see the green graph is. So that is tan, is only positive there. And in the last 90 degrees, between 270 and 360, you can only see the red graph above the x-axis, which is cos. So only C is, cos is positive between 270 and 360. So if you think of it like a quadrant, so remember we measure angles from the positive x-axis all the way around. Then the first 90 degrees all, so all are positive. A for all. In the second quadrant, sine is, which is so sine. Third quadrant is tan. And the fourth quadrant is cos. So what you have to remember is the acronym ASTC. So find a way of remembering that. ASTC, starting from 0. Okay, so let's use this to hopefully find exact values, trig values, using some information that we're given. So find without using a calculator the values of sine theta and cos theta, given that tan theta is equal to 5 over 12. And theta is acute. So theta is acute means it's obviously between 0 and 90. So theta is here. And remember, it's A, S, T, C. So we're in this quadrant, which means all are positive. So all our values for sine, cos, and tan would be positive. Next thing we do know is tan theta. So if you draw a right angle triangle, because theta is obtuse, then tan theta is equal to 5 over 12. But tan theta is obviously TOA. So in SOHCAHTOA is TOA. So that means the 5 must be opposite and 12 must be adjacent. So opposite is 5, adjacent is 12. So in order to find the, obviously, hypotenuse, I need to do, so hypotenuse is equal to square root of 12 squared plus 5 squared. So the hypotenuse is equal to 13. If you put that into your calculator, you get 13. So 13. So that means if I want to find sine theta, it's opposite over hypotenuse using SOHCAHTOA. So opposite is 5, hypotenuse is 13. And if I want to find cos theta, it's equal to adjacent over hypotenuse, which is equal to 12 over 13. So that's part A, because all were positive. So all of them are positive, so they're positive values, because in the first quadrant. Let's do B in a similar way. So sine theta and tan theta, given that cos theta is equal to minus 3 over 5 and theta is obtuse. If theta is obtuse, it means obviously it's in the second quadrant. So that means if I write ASTC, then only sine is positive. So because we're in this quadrant, only sine is positive. Okay, So tan, so if I want to write it down, I'll have sine is positive, cos is negative, which we do have, and tan is negative. So we always draw a right angle triangle to help us find the value. So theta, cos theta is equal to negative 3/5. So adjacent over hypotenuse, adjacent over hypotenuse. So adjacent must be 3 and hypotenuse must be 5. So that means opposite will be equal to root of 5 squared, take away 3 squared, which is equal to 4. That's 4. So if I want to find, first thing I want to find is sine theta. Sine theta is positive for my diagram here. So it's opposite over hypotenuse, which is equal to 4/5. And if I want to find tan theta, I know tan theta is negative. And then it's opposite over adjacent, which is negative 4/3. See, cos theta and tan theta, given that sine theta is negative 7/25 and theta is between 270 and 360. That means, so this is theta. So all ASTC, or all silver teacups, as I remember it. So we're looking at this one. So that means C, which means sine is negative, only cosine is positive, tan is negative. So I should have written from here, sine is positive, cosine is positive, tan is positive. Okay, so remember I've got draw a right angle triangle to help me find it. Theta, sine theta is negative, which makes sense with my diagram. So opposite is 7, hypotenuse is 25. So if I want to find this, it'll be 25 squared, take away 7 squared. 25 squared, take away 7 squared, square rooted, which gives me a value of 24. So that means if I want to find cos theta is positive from my diagram. So it's going to be adjacent over hypotenuse, which is 24/25. And if I want to find tan theta is equal to, it's a negative value, it's opposite over adjacent, which is equal to 7/24. So those are my answers. 1, 2, 3, 4, 5, and 6. Okay, given that sine theta is equal to 2/3 and theta is obtuse, find the exact value of A cos theta and B tan theta. So because theta is obtuse, I know it's in the second quadrant. So it's here. All silver tea cups. So because theta is obtuse, it must be this quadrant, which is S, which means sine is positive, cos is negative, tan is negative. And then we have the triangle, right angle triangle. Sine theta is opposite over hypotenuse, so opposite over hypotenuse. So opposite must be 2, hypotenuse must be 3. So if I want to find out adjacent, it's 3 squared, take away 2 squared, using Pythagoras, which is 9, take away 4 square rooted, which is square root 5. So if I want to find A, which is cos theta is negative because we know it's negative here. And it's adjacent over hypotenuse, which is equal to negative. Adjacent is root 5 over hypotenuse, which is 3. That's A. B is find tan theta. Tan theta is TOA, so opposite over, again, tan is negative, so negative, opposite over adjacent, which is equal to negative. Opposite is 2 over adjacent, which is root 5. We don't like a third in the denominator, so rationalize it by multiplying by root 5. So end up root 5 times root 5, which is 5 at the bottom. Next question. Given that cos theta is equal to 3/4 and theta is reflex, find the exact value of sine theta and tan theta. Now, theta is reflex means it's between 180 and 360. So obviously that means it's either here or here. Now all ASTC, because cos theta is positive here, it must be in one of the bottom two quadrants, but where cos is positive, which is obviously the fourth quadrant. So that must be because theta is positive here, yes? Because theta is negative in the third quadrant, so it can't be that one, which means sine is negative and tan is negative. So we're looking at this one. So we're using this, and we know obviously if I draw a right angle triangle, we've got theta. Cos of theta is adjacent over hypotenuse, so this is adjacent, this is hypotenuse. So adjacent is 3 and hypotenuse is 4. So if I want to find this, which is opposite, is 4 squared take away 3 squared square rooted, which is equal to 16 take away 9 square rooted, which is square root 7. So A, if I want to find sine theta, I know straight away sine theta is negative. Opposite is root 7 over hypotenuse, which is 4. Okay, B is tan theta, which is opposite over, again it's negative first, opposite over adjacent, which is root 7 over 3. Okay, next example. Given the angle A is obtuse and cos A is equal to negative root 7 over 11, show that tan A is equal to negative 2 root 7 over 7. So that means, again, I'm going to draw my quadrants in. It's obtuse, means it's in the second quadrant. So theta A, S, T, C. So it's the S we're looking at. So in this quadrant, I know sine is positive, cosine is negative, tan is negative. If I draw my angle out, theta cos A, well, not theta actually, this is A. My angle is not theta in this case, my angle is A. Don't confuse it with that A. Okay, cos A is equal to, so negative root 7 must be the adjacent, and sorry, negative is negative because it's obviously because of the quadrant. Root 7 must be my adjacent, and root 11 must be my hypotenuse because the square root, this is the same thing as root 7 over root 11, so negative. Okay, so if I want to find this, it's just going to be root of 11 take away 7, which is root of 4, which is just 2. Okay, so if I want to find tan A is negative. We know it's negative from this information. And I know is opposite, which is 2 over adjacent, which is root 7. Again, this is, we don't like a third in the denominator, so we need to multiply top and bottom by root 7, which we get negative 2 root 7 over 7, which is what I wanted. Okay, the diagram shows the triangle ABC with AB equal to 12, BC is equal to 8, and AC is equal to 10. Show that cos B is equal to 9 over 16. So cos B, so let's call this B, let's call that little a, and let's call that little c. So if I rewrite the cosine rule, cos B is equal to a squared plus c squared, because it's the other two. So it's the other two, not the one opposite b, minus b squared all over 2ac, which means cos b will be equal to 8 squared plus 12 squared take away 10 squared over 2 times 8 times 12, which gives us 9 over 16, which is what we wanted. B, hence find the exact value of sine B. Okay, so if I draw out my angle, this is B, then opposite, this must be adjacent, so cos B is adjacent over hypotenuse, so adjacent must be 9 and hypotenuse must be 16. Then if I want to find opposite, it's 16 squared take away 9 squared, which if I put into my calculator, I get 5 times root 7. Okay, because all these angles are acute, A and B acute, then that means sine B is in the first quadrant, so all of them are positive, so you get, so this is B, so this is all, which means sine is positive, cos is positive, tan is positive. So sine B will be equal to opposite, which is 5 root 7 over hypotenuse, which is 16. Okay, the last question. The diagram shows triangle PQR with PR is equal to 8, QR is equal to 6, and angle QPR is equal to 30. A, show that sine Q is equal to 2 over 3. Because we have corresponding opposite angle and length, it means we have to use the sine rule. So and because we're trying to find an unknown angle, I'd use using sine A over A is equal to sine B over B. I get sine of Q over 8 is equal to sine of 30 over 6. So that means sine of Q is equal to sine 30 over 6 times 8. Put that into your calculator, sine of Q is equal to 2 over 3. Part B, given that Q is obtuse, so if Q is obtuse, it means it's in the second quadrant. So this is Q, or as ASTC. So we're looking at S, which means in that quadrant, sine is positive, cosine is negative, and tan is negative. So we've got Q, sine is equal to opposite over hypotenuse. So opposite is 2, hypotenuse is 3. So this part will be 3 squared take away 2 squared, which is 9 take away 4 square rooted, which is root 5. So if I'm trying to find, given that Q is obtuse, find the exact value of cos Q. Then cos Q, because cos is negative, the negative, adjacent over hypotenuse, adjacent is root 5 over hypotenuse, which is 3.